Hi guys, and welcome back. As I said previously, we are now going to look at reduction formula, but what I want you to understand is that reduction formula is essentially what we call a rotation, okay? So that's exactly what I'm going to do here. I'm going to rotate this triangle. I've got a nice triangle here, guys, that I am going to rotate. Let me just put my triangle back, and I'm using GeoGebra Classic app. And guess what? You can also download this on your cell phone. Okay, so let's get to have some useful apps in our cell phones for learning. You may want to go ahead on your store there, your Play Store or your iStore, Apple Store for the apps there, and get this app. It's of course you'll do that when you're done watching the video to just have some exploration. So we're going to do the reduction 90 plus theta. And what I want you to pay attention, close attention at, is this coordinate here, or the point D. The coordinate of D is 4 for the x value, and then 3 the y value, okay? And I want you to see what will happen. Here's my angle theta. Let me measure this angle theta. I'm gonna measure this angle, and let's see what it is. There it is. It's 36.62 degrees. Okay. Now 90 plus theta would mean I must actually rotate this line, the line A, you see small a there? I must rotate the line A 90 degrees anti-clockwise. Okay, that's what 90 plus theta means. Okay, remember what I said, trig is very linked to geometry. Grade 9, you guys dealt with some transformations. You did a reduction and enlargement. You were doing a reflection about the x-axis, about the y-axis, and the line y equal to x. And I believe you also did rotation about a point, and that is what we are doing here. I'm actually going to transform this triangle, okay, by rotating it 90 degrees anti-clockwise. So you may want to go back down to grade 9 and have some fun, see how you did this reduction. If not, of course, you are welcome to follow with me. So I'm going to go ahead now and rotate this figure here. So I'm going to rotate this figure here. Of course, I'm going to select rotate about a point, not about around. So here is my object, the point origin. Now, what is the angle? We want 90 plus theta. So I'm going to go 90. You see now I'm saying counterclockwise, in other words, anti-clockwise. So because I'm saying 90 plus, if I said, if I wanted to go theta minus, then I would just say clockwise. Okay, so there I am. As I said, what I want you to pay attention at here is the point D. Let us look at the coordinates of D right now. Remember, D has the point XR, okay? And that point XR, guys, is, sorry, not XR, XY, is the one that helps us to determine our trigonometric ratios, okay? As to what will be the sine of theta, what will be the cos of theta, and etc. So let me maybe write down these coordinates here. X is 4 and y is 3. But for d prime, what is x? We can see is minus 3. Ah, okay. Uh, that was a slippery one. Minus 3 and 4. And I hope you can see this is what you learned. You know rotation about 90 degrees. Actually, if you had xy, then you're gonna have a minus y and x, as long as you are rotating 90 degrees anti-clockwise. And that is exactly what I have. Now, what is happening here? R, remember, stays the same, does not change. So we are going to investigate something. By now, theta, here's my theta here. Now, here is 90. Okay, hence we call this thing, this quadrant, hence we refer to this as the quadrant where the 90 plus theta reduction takes place. So 90 plus theta. There we are. I hope we are all clear. Now, let us note a few things. Sine theta in this triangle, in the first quadrant, in other words, I'm in quadrant 1 here, quadrant 2 down there, quadrant 3 here, and quadrant 4 here, okay? So sine theta is opposite. What is opposite? It is the y value, which is 3. So this is 3, and this is 4 here. In this case, x here is minus 3. So that side there is minus 3, and y in this case is 4. Okay. So sine theta is opposite, which is 3. And what is hypotenuse is r. Okay. If you know what we call Pythagorean triples, you will have seen right away that the hypotenuse is actually going to be 5. Otherwise, if you doubt, just try out the theorem of Pythagoras, x squared plus y squared. So you're gonna have 4 squared, which is 16, plus 3 squared, which is 9, that gives you 25, and the square root of 25 is 5. Okay, so r here is 5, and it is the same thing here. 5 is r. So cos theta, okay, is what? Adjacent, which is 4. Remember, theta is what? 36.62. Okay, 4 over what is r? 5. Okay, we are dealing with the 90 reduction, right? And if you like, we can write tan theta here. And what is that? Opposite 3, adjacent 4. Remember, let me indicate theta is 36.62 according to our diagram. Now, next thing that we're going to do, we're going to come and do the same thing in this triangle. So if I look for sine theta, let me use a different color here. If I look for sine theta in this triangle, okay, what is my opposite? So let's, for argument's sake, let's use this as my reference angle, okay? As a matter of fact, remember what we did in grade 10? Whenever we're solving triangles, this is what we always did, okay? We had this right angle here, and there's my reference angle, okay? As a matter of fact, I should not even say sine theta. I should actually say sine 90 plus theta, because we are using the coordinates of 90 plus theta, okay? I hope you follow that. So let me just erase a little bit here. So let us see what, excuse me, let us see what do we have for sine of 90 plus theta. And you will remember very much that this is just a matter of co-functions. So if I look for sine 90 plus theta, so what has happened to what? Y? Yes. Let's see. What has happened to y in that case? The y value, we can see it is positive here. It is, but I want you to look at it in this case. What is the y value actually? The y value, okay, let me write it, 4, okay? And what is r is 5, okay? But let us see what is 4 over 5 in this case. 4 over 5 is actually what? Cos. So do we see that actually if I use the 9, instead of figuring out the angle 90 plus theta, the ratio of 90 plus theta, I can actually just figure out the cosine of theta. Okay, so the reduction says, instead of doing this entire rotation as I'm doing here and figuring out what the angle is going to be, just go for cos theta, because you're going to get exactly the same ratio as I showed you in the graph previously. Let's see what also happens with cos of 90 plus theta. Okay, what is happening there? And by the way, remember our theta is what? 36.62. Okay, so what is happening? We know that cos is going to be the x value, right? What is the x value here is -3. What is r? 5, okay? -3/5. But what is, okay, here we said this is cos theta, okay? But what is 3/5? 3/5 in this on this side is sine theta. So actually this is just negative sine theta. Oh, brilliant, isn't it? That is excellent, guys. Now we're gonna throw in the 1 for 10, but to throw in the 1 for 10, we probably need to figure out first what is cot theta on this first quadrant. What is cot theta? Cot theta, we know, will be the reciprocal of tan. So instead of having 3/4, we're going to have 4/3. So let's see what happens to tan 90 degrees plus theta. What is happening here? We know tan, it will be y. In other words, it will be opposite, okay, over x, which is what? Adjacent. Oh, guess what? This is just -4/3. But 4/3 is cot, so this is just minus cot theta. Okay, and that is just the long and the short of my story, folks. This is how we figure out the reductions 90 plus theta. So what is this saying? For argument's sake, we know theta is 36.62, okay? So this is just saying, look, instead of pressing in your calculator sine 90 plus 36.2 and figuring out the answer, just go ahead and press cos 36.2. You will get the exact same answer. Remember, the lazy mathematician hates writing a lot of stuff, wants shortcuts, and that's exactly the point here. Instead of just writing these things 90 plus 90 minus, let's just take a shortcut the simplest way. Okay, we have seen in the graph that there's always about two values. If we ignore the sign, four values, at least four values of x, that will give us the same ratio between 0 and 360 degrees. That's what we established in the previous video where I was having a chat with you about this whole reduction. I'm gonna pause it here, folks. In the next video, I am discussing with you the 180 minus and hopefully the 180 plus. Remember, I try keep these things short so that you will not feel like I'm taking a lot of your time. So until then, I'll catch you guys later.